All right, these are the answers to page 99 and 111. So for the 99, we're doing inverse functions. And for this one, you're supposed to match this graph up with the graph of its inverse. Now, there's some things about reflecting a graph about the line y equal x that we might have talked about in class. But to me, what I think is easy is just to kind of look at it almost point by point. So for example, this is the point 0, 1. And an inverse just takes your x and y's and flips them. So that means the point 1, 0 is on your inverse graph. And so then what I did was I went and looked at the 6 examples, and the only one that goes through the point 1, 0 was letter A. And if you look at the rest of it, it kind of makes this shape here, and then you have that going like this here. All right, that nice reflection. Similar idea here. If you look at this, we have the point 0, 0. So that means flip it around. 0, 0 should be on my inverse graph too. And the only one that looks like that was letter D. And if you put that graph out on here, you'll see that that has that reflection as well. Right? Then 30 and 36 want to know, do these have inverses? So well, you can see if something's a function by using the vertical line test to see if every domain has one range. But when you say, does something have an inverse, you're going to use the horizontal line test. Does each range now have just one domain? And in this case, the answer is no. This range here has 2 domains. So if you tried to make an inverse, you're going to have a problem because this range won't have just one domain to go to. So we would say this one does not have an inverse. But if we graph this one here, take our calculator, plug that in. I'm going to go zoom 6 to start with here. And sure enough, this is just our normal cubic graph. Horizontal line test hits 1 point at a time. So we would say based off of that graph, yeah, this definitely has an inverse. So we're just using this horizontal line test when we talk about does something have an inverse. Now, this we're going to say for sure has an inverse. We want to find it. There's 2 different ways to go about finding the inverse of a function. One's kind of algebraic, and one, I like the second one, but I'm going to show you both. All right, so first things first, you change from function notation into y. It just makes life a little easier to work with. And then the actual inverse now, we're going to flip this around. We're going to change the y and the x. So now this y right here is the inverse function. It's like that f to the negative 1 or whatever. What we want to do is get that by itself. So we're going to subtract 1, and then we're going to take the cube root of both sides to get rid of that cube. That's equal to y, which we said is our inverse function. All right. And if we were to put this on a graph, again, we're going to see is that graph that reflects around there. We could do this on a calculator. I'm not going to be too concerned here. What I want to do instead of the graph is show you the other way to come up with an inverse. So we have our function f of x equals x cubed plus 1. What I'm going to say is if you were to put something into this function, what would you do? For example, if I put the number 5 into it, what would be the very first thing I would do? And the first thing I would do would be to cube it, right? I would go 5 times 5 times 5 based on the exponent, and then I would add 1 to it. This is what this function is, right? This is what it tells you to do to anything you put into it. So when I say, well, what about the inverse of that function? Okay. Well, the inverse of this function is going to do the exact opposite in the exact opposite order. So instead of cubing and then adding, let's go backwards and do the opposite. Instead of adding 1, let's subtract 1. Instead of cubing, let's take the cube root. So now I have an x value. I'm going to subtract 1 from it, and then I'm going to take the cube root of it. And it's the exact same thing that we had the algebraic way, right? It's just kind of what I like about it is it's kind of intuitive. Like it helps you understand exactly what an inverse is. It's the opposite. It undoes a function. Whatever the function tells us to do, this does that opposite of it. All right? But you can do either way. Some people like this, some people like that. Doesn't matter. All right, now jumping into page 111, we're doing proportionality, and they wanted an equation where x is directly proportional to y, and you have this relationship going. So in a direct proportion, you have some constant that keeps these in balance. Kind of think of it like when you get paid for your job. maybe you make $10 an hour, then K would be 10. X would be the number of hours you work, Y would be your pay, right? This is just keeps these things in balance. And if we put these numbers in, 14 equals K times 2, then it's pretty easy to see that our K value is 7. So we have an equation, Y equals 7 times whatever X is. If these are directly proportional, then this is how those two are related. All right? Similar idea here for 30. These were directly proportional. When we put $5,000 in the bank, we got $187.50 for interest. So let's take $187.50 equals K times 5,000. And now if we divide by 5,000, let's just take our calculator real quick and go 187.50 divided by 5,000. Oh, not 50,000. And we get 0.0375, so 3.75% is what we were getting, 0.0375. And so our interest is 0.0375 times our principal. There's our equation. Okay. The rest of these are asking us to write. We don't have to evaluate anything. We just simply have to make an equation. So it says y varies directly with the cube of e. So our v varies directly. So we're going to have that k, and because it's direct, we're going to multiply the cube of e. That's e to the third power. And so we just kind of read it and write what we say. Same thing here. H varies inversely. So we've got h, we're going to have that k. Inverse means we're going to divide instead of multiply. And we're going to divide by the square root of s. So square root of s. Right. 44, z is jointly proportional. What that means is that it's direct with more than just one thing. Okay, so we got our k, and we're going to multiply by couple different things. In this case, it's going to be the square of x, so x squared, and the cube of y, y cubed. We don't have a second k or anything. It's just there as the one-time constant, but it's going to be both of these things here in this. And so similar idea here. R is jointly proportional, so R equals, then we got k. It's proportional to s, and the difference of L and S. So then we're going to go L minus S. And then there's our equation for that. So not too bad.